Well, hi, and welcome to my shop here this morning. It's the 27th of September. And so what I'm going to be focused on today, and I hope to really nail down, is why are these two resistors here so hot? And I still think they're getting too hot. And there's quite a number of factors around their operation. I'm going to have to kind of work my way through each one of them and ultimately discover that either there's something wrong that can be fixed and reduce the temperature of these two guys, or this is how they're supposed to be. They're supposed to be this hot, which I find hard to believe. So now if you watch lots of my videos, you always see this meter sitting idle, but you see it bopping around here with my voice on it. That's me just trying to get a better grip on the audio levels in my shop, trying to have meters within eyesight. So you know, I'm gazing down this way, so that's why this one's going to bop around with my voice. And just on that note, just so you know, I also have these lights which flash on peaks, and then I also have these averaging meters up here which kind of average out the sound, so I can kind of see where we are on the averages. The problem is my eyes are looking over here and seldom looking up there, so just trying to improve the audio levels, which sometimes are very tricky to keep correct here. Okay, enough of that. Enough of what I'm doing in my shop. Here's what, yes, I've been busy. Even though I haven't posted a video, I have been busy studying all this and other stuff. So I've made a pictorial map of this part of the radio. It's this lousy diagram here. I have to say, like, this resistor is this resistor, right? And I've numbered them all, R38, 42, R11. And sort of just drew the picture as best I could from the radio. And then I've redrawn this into this arrangement here, which shows much more distinctly what's going on. We're going to look at this with a closer camera while we work away on this. In fact, we might start right there. Now, one of the things that I think is a little interesting about this whole problem is that this resistor appears to have been overheated the worst of all of them, but it's not hot now. Normal operation, this guy's actually quite cool. So, you know, some of the questions that we should really have is, well, what is being fed through these resistors? What is drawing the current that's going through them? Usually in a problem situation, the answer is a shorted capacitor or something like that. And I've kind of worked my way through all the peripheral problems, including shorted capacitor. Not completely. There are still some original capacitors in here, like there's a mica one right there. And then there's a round of replacement capacitors. An example is this big orange one here. And then all these bright yellow ones are the ones I've put in, except for this one here. That's also a 20-year-old capacitor. You can see I've even marked one here. I stuck a clip lead on it, so I won't forget to check out what is going on with this capacitor, which I suspect is probably bad, but I don't know that to be the case. The bottom line is, I think I've changed all the capacitors that can affect these resistors. I think there's nothing in here anymore that can affect these resistors. So, you know, the conclusion I'm stuck with right now, and I'm not settling for this, is this is the way they operate. They operate at what is probably 90 degrees C when full B plus is applied. That's hot. That's really hot. And you know, they've painted it with paint here. I'm sure they never intended this resistor to run so hot the paint would melt off of it. See, same thing's happened with this one. This one's burned right off. I'm sure that wasn't intentional. This is what they want them to look like. This is another high wattage resistor. It's even in the string here of resistors. It's this one. It looks perfect. Okay. Let's switch to looking at the circuit diagram here, and we're going to look at my hand-drawn version, not the schematic itself, but the schematic does match this. So, just a quick. So this point here is where B plus is fed into these resistors. So I've redrawn it like this: a bus bar, a B plus bus bar. Right on that point is a capacitor to ground, and it looks like it's 25 microfarads. That doesn't make sense. So this is maybe a decimal point is missing here. I'm not sure. That's a capacitor I replaced already. 25, I don't think it's 25. Here it is here. And then what it really amounts to, this schmozzle, it really amounts to two sets of resistors in series. One here and one set here. And they're just running from B plus down to the chassis. So there's just voltage dividers here. But they're not so simple because there's current being taken off in different places. Now, I've marked the two resistors that are hot. This one and this one. See, I use this artistic technique here of drawing the heat waves coming off of it. So this guy's hot, this guy's hot, this guy was hot, but he's okay now. So we can take a guess at this one. This one went south because of this capacitor failure, which has been replaced. Replaced and re-replaced by me. So that's what happened to that resistor, but that's not happening now. Since I've had this radio, this resistor's never been hot. So this one has to be taking the same current as that one. This is only 1,000 ohms. This is 20,000 ohms. Okay, somebody's at the door. Let's go see what the story is here. The poor cat. You can't ignore him. Yeah? You want to go that way, eh? Which way? Show me. Oh, you'd like to go to the garage. Okay, to the garage. Go ahead. Go ahead. Oh, another one. Come on. Go ahead. Go on out there. Go on. They really don't want to go in the garage. They really want to go outside. Sometimes the garage is the way to get outside, but sometimes it's not. So they're very hesitant. Now, after that distraction, let us get back to what we were doing here. Okay, I just left the garage door open. So this guy is overheating, and this guy is not. Look at this. This one, 750 ohms, and there's a capacitor here. What's connected here is pin 4 of the 6K7. So I've been doing a lot of reading on screens and things like that. This is a screen connection, I should have said that. This is pin 4 screen connection to the 6K7. The job of this tube is the expander tube. So we go down a little further. Oh, let's just hold it there. So the current in a 6K7 is something like 3 milliamps on the screen. Depends on the B+. Could be 4 milliamps. Maybe it's 5 in this radio. Okay? On the 6J7, it's only half of a milliamp. That's not very much. The 6J7 comes into picture down here. That's going to the screen of the 6J7. So we can calculate the current, what it should be in here. We can also, when the set's operating, measure the voltage drop and do other things to really determine the current flow in here, which is what I think we really should do. So what could be going out here, or coming from the tube, you could put it that way, from the screen, could be 4 milliamps. 4 milliamps on pin 4. So we do a quick calculation. Let's just throw in an extra milliamp down here. So make it 5 milliamps flowing through this thing. So what's 5 milliamps? Okay, now I'm going to turn to my so powerful computer here. That's my last calculation. I did it with 4, I think. Let's try 5 milliamps. So it'd be 0.005 times 0.005. So that's I squared times the resistance. I squared R, 27,000. 27,000. So we're getting we're getting half a watt. half a watt. When I think about those resistors, you know, this is the one we're talking about right here. Half a watt. So this gets up to 55 to 60, and this is getting up to 75 with reduced B+, because I still have in this radio a 5U4 rectifier where a 5Y3 should be. Now, earlier experimenting showed just a 5% change in the B+. I didn't think it was enough to even think about. And that's why I've continued with that stronger rectifier tube. So B+ up a little bit. And measured B+ in here is quite a bit higher than what is suggested in the somewhere along the line. There was some suggestion. I think might have been me reading in the tube manual or something like that. That was it 325? I think it's 325, which is kind of high. The screen maximum voltage, the 6K7 is 300. That's the max, and typical is 250. So we got an extra 100 volts on the screen of this tube here. And that might be enough to generate, you know, another couple milliamps in here maybe. So that's this guy. And just to clarify, the only thing that can be happening here is this screen current going into the tube. It's the only reason this guy can be hot. So we could start asking questions about why is the screen current high in this tube? Is there something wrong? Like, is its bias off or something like that? So quieting this guy down or cooling him off might be all about figuring out what's going on with this tube here in this rather unusual expander circuit, decompressor. Now on this side, I haven't analyzed this one all that much with my own little head, so let's do it now and see what we come up with here. So we know the current can get through a 1,000 watt resistor and not smoke it. And this is a small, this is like a 1/4 watt resistor or something like that. This guy is cooking and this guy is not. So R44 is that beautiful yellow resistor there. It's just glowing in my camera shot, and this is the one that's cooking up, and they're in series. These two are in series. But I think there's probably, well, I should say this is not the whole picture. There are other components wired in here. There are more takeoffs. I didn't copy them all down. What I've done is I've identified, I believe I've identified what is going in and out of these two hot resistors. So good question is, why is R44 so darn cool? Well, R18 is on fire, and they're similar. This is double the resistance. It means double the wattage. Oh my gosh, double the wattage here. So maybe we'll start with this curiosity here. How can you possibly have the same current going through these two resistors, and this one's the hot one and this one's not? Because there's something being taken off right in here. So I think I'm going to have to put the real schematic up on the screen and study that. So give me a moment here. I got to make a little video adjustment. So this is the main radio up here coming along, audio, speaker, all that kind of stuff. Down here are these two special tubes that drive the expander function in the radio. Something I haven't really seen before, especially in such an old radio. I was kind of shocked to see this. So this is an attempt to correct any compression that may exist in the recording you're listening to. Excuse me. And how exactly it works, I don't know. But this is a curious way of using these tubes. So let's take a look at the resistors first. If you remember, I had a line of resistors. Here it is, right here. This one's overheating. This one's not. Well, none of these are down here. Just this one. So you can see here's the B+ developed here. Filtered. And then here's the B+ supply. It says right there, B+ filter choke. That B+ supply, one of the first things it reaches is this resistor. If I can put it that way. And what would be flowing in this resistor is whatever current can be drawn out of this screen circuit plus whatever is falling through these. So I could measure the resistance, measure the voltage drop, calculate the current flow in here. So that's the story there. The only thing possible is this tube. Now what's going on with this tube? Let's just take a look at it. So the plate, the plate is hooked up to this switch that doesn't work right. And currently, what have I done with it? So the switch is just sitting there. I think I left it in a position. I think I left it in the off position. Did I? I can't remember. So this switch might be implicated. For instance, if one, this is a double pole. I'm sorry, it's a double throw, double pole. Not really, because this pole is just off. What the point is anyway, there's two mechanical switches inside here. One of them is operating, one of them is not. That could put the radio into a state never engineered for. No one ever expected that to happen. And that could be what's going on down here. It could be doing something. So suffice it to say, that's a possible problem. And then it's getting its B plus from way up here through R19. All the way from here. So this tube down yonder is getting its B plus through this resistor, this resistor, this resistor. And there's a signal coming through here. Oh my. So I think when you throw these switches, what do? You click in these two into the circuit. You have this off. Oh boy, I don't know what I'm going to do. I didn't really intend on studying the Sparton schematic today. I've been par for the course. Okay, well, let's just suffice it to say that it's possible the problem lies up in there. Another possibility is this tube is not operating normally because it doesn't have a proper grid supply. So the grid is, that's interesting, isn't it? This is where's the cathode? Oh, cathode and grid are shorted in this tube. So what's that mean? That means the grid is just more cathode? A little more cathode. Okay, now this is the suppressor. Yeah. Oh, okay, look what they're doing here. Everybody, look what they're doing here. They've got the signal coming out of the expander amp on the plate like any other tube. This is I'm assuming at this point this is operating like any tube is. Not on this side. The signal comes across here and is applied to the suppressor grid. This must be how they get the funny characteristic of amplifying loud things more than quieter things. It must be some characteristic of the tube that somebody discovered and could be utilized this way. So the grid down here is out of the picture. They're using the grid closest to the plate, and the plate output is developed across this resistor, and that's going to become audio, I guess, heading on into the amplifier at that point. I guess that's what's happening here. Then the screen is just a screen. The screen is just doing what screens do. It's hooked up to the B+, but way ahead of all these other resistors. Sometimes you can just connect the screen through a resistor right to the plate wire. it'll work quite fine. So tube operation is extremely complex. What's going on in here? Much more complex. This is what I've been learning. Much more complex than what I had ever imagined, and I imagined it was quite complex. So there's a lot of stuff going on in here to understand how you can use the suppressor as a grid and all this other stuff. Far be it from me to explain any of this right now, or maybe even ever. So what can we do here? So I think it's really a question of getting a grip on what this current is here. What is the current flow in this part of the circuit? A couple of approaches. One is, voltage drop. That means I have to know this resistance exactly. So that's what we can do about that. What is the current flow through this tube, and why is it not what it should be if that's the case? And if it is the case, this is putting out 3 milliamps here, 2 or 3 milliamps, and that's what's causing the heat. Then there's not much that can be done about this. Now the other one. Let's go back to my bench top here. Okay, now this guy, R11. So how can R11 be cooking an R44 cool as a cucumber? Oh yeah, because I thought there was something else in here. Let's look and see. We'll look at this spot just beyond the cooked up resistor here. So here we go. So just beyond. I think I gotta change my focus. Whoa! Hold on a sec here. It's getting a little closer. Maybe like that. No, that's way too close. So, not to be fooled now, this is not a pin terminal. This is a tube socket with spare connection terminals built into it, which the radio manufacturer has utilized. So he's got this resistor connected here, and there's a mystery wire. Well, see, this wire comes up and it's encountering this resistor, which is cool like a cucumber, and another wire. Not on my diagram down below. So going back to this one, where's this wire going? So I'm just trying to make this. Okay, it's this one that I'm touching. It goes down and disappears. Where the heck is that going? Well, there's two wires coming in there, kind of twisted around each other. They look like a brown color, and this doesn't really. Well, there's two wires heading down there, and two wires appearing. How do you make mistakes doing this work? This is one definite way. Let's see if I can wiggle those wires. Grab here. I don't know, I'm going to grab that other one. Okay, what can you see around the top of this radio? This is nothing. Oh. So are they heading into these cans? No, they can't. They can't be heading into the cans. Because the cans have their own hole through the chassis here. Those are the can wires. It can't be the can wires. Well, what are these other wires doing? There's a whole pile of them heading down there. Wow, you get a short circuit here. Messing around with these wires too much, or these. So to there. Well, you know, I think this has to be the wires. This has to be the wires. So what's it doing? So they are connecting to, we can't tell which is which. Pin 1, 2, pin 3 and pin 4. Plate and screen, I'm guessing. And one wire carries on, but the other one of them just terminates there. Is that right? Oh, there's another wire in there. It's like one comes to a terminal 4 with 1, 2, 3 wires on it, and the other one is terminal 3 with 1 wire. And what tube is that? That's the second tube in the radio. That's the second tube in the radio. Second tube in the radio. Okay, so this is a very fiddly video. In case you haven't figured this out yet, it's going to get even more fiddly. Second tube in the radio is. Look at a diagram to be absolutely sure. Second tube means one at the front, 6A8. So those wires are going up to the 6A8. Okay, let's take a look at the schematic here and see if I can manage this. Wow, 6A8. So the 6A8. 6A8. Huh. I'm hugging because there's so many grids in here. Now they've drawn this one different than the others. They may have done that because they just didn't have space in their circle to fit all the grids in. They have just done that from a drafting point of view. So here's the grid cap. Appears to be coming out of the antenna circuit. Coming from here. So antenna through these coils up into here. There's the grid cap, and then out over to here and down onto this grid. Wait a minute. Why are all these going? This is probably all screen stuff. R11. There we are. R11, R44. Those are on my diagram. Do I have these drawn right? Let me just take a peek here. R44. R11. Maybe I don't have these done right. So we come down right off of all the screens with this big quieting capacitor over here. C21. I better check that guy too. Probably already changed it. Come down here and we got this. Band switch. I remember looking at this earlier and wondering, well, what the heck is this all about? So it would appear that throwing the band switch introduces this resistor R10 on broadcast and long wave, the higher short wave bands. This resistor's out of it. So what would this resistor do? Clicking it in can only pull this voltage down a bit. I would think. That would just reduce the screen voltages. Well, why? Why would they do that? Why not have the same screen voltage the whole time? What doesn't matter? So clearly the lower frequencies, for some reason, they want the screen to have more voltage on it, I guess. I don't know. So I've got my diagram drawn wrong. So R11 connects to what I think is the B plus line. Show me. So we follow it up here. Yeah, through the primary. It's got to be the B plus to the plate. So this is the B plus line. So B plus enters R11. I got this drawn completely wrong. R44 goes to ground. So this is a voltage divider right here. R11 and R44. R11. 18K. R11. R11 is the hot one. R11 is the hot one. I got 44 in my head. R11 is the hot one. So this guy's carrying everything. He's got him, his current, he's got this guy's current if it's there. Oh, that's interesting. Switch this to short wave and this guy should cool off a bit. What is the value of R10? What is R10? R10 is, okay, it's not small. It's just a quarter watt though. 22K. And how's that compared to R44? So R44, I've got it written here. R44 is 47K 1 watt. So these resistors, these two guys, are both going to the chassis. This one's got a switch. This guy is cooking and is supposed to be 47K. This guy, assumingly, I have to find this. Assumably, it has not cooked up, and it's just a small guy. Wait a minute, R10. I shouldn't say small guy. Let's look again. R10. Yeah, 22. So it's half the size. These half the size. This is 50. This is 25K. This guy's frying, and this guy's, well, we better find this R10. I better correct my diagram here, because I've got it really quite wrong here. So it was R11, R44 in series to ground. Okay, let's look at my diagram. What did I do wrong? R11, and then R44. Oh, wait a minute. No, I'm not quite so wrong. Now that I look at my own diagram again, I'm not quite so wrong. That's something you really don't want to hear your doctor or your pilot saying. So R11, and then all the current goes into R44. So I had this backwards in how I was talking about it. This wire, I never did figure out where it went. Whoops. I was partway tracing it down there when it was 3 and 4 on the 6K 688. 3 and 4 on the 688. 3 and 4. So 3, interestingly enough, is the plate, and 4 is the screens. Is there two screens in here? That looks like a suppressor. Appears to be connected as a screen. That could just be poor drawing in here. 688. Can't say I've ever seen where you hook up this grid to the screen. Maybe though. Maybe. Because you want to, you put a screen in here in order to change the apparent capacitance between this grid and this plate. So in goes a screen, and there's no suppressor. No suppressor. So how does all this work? There's a control grid. Well, I got this tube right upside down here in my head. No way. So we got a grid here. Must just be going out on pin 5. Looks like it's going down to the oscillator. Then this grid. Oh, I don't know. Well, let's say on this wire there's going to be screen current. Yeah, from all these tubes, all adding up. So there's going to be quite a bit of current going through here. And the voltage divided This is literally to pull current through this resistor to drop the voltage of this. You want the screens to be a little less than the plates normally. Certainly never more. So the question is, R10, what happens when you throw this switch? What's the resistance of these resistors? That's the story on this side. Why don't we start with this side? So let's see if we can measure the resistance of R11, R44, and find R10. We need to find R10. Okay. Okay, now, can you possibly sort this out? Okay, as horrible as this diagram is, and you may not be able to see it on camera because of lighting issues. I need to hold this up here like this. So this is R11, this is R44, there's an R10 coming off of here. So we got to find that R10. Now this connection here is actually spread over this terminal and this terminal. One of these goes off to the screen. That's the, we'll assume that's the screen wire there. So I've got another resistor in here, R42. I'm showing 42 as being ahead of 11. Well, that's not what it showed in the schematic at all. 42 is somewhere else entirely. The B plus is attached here. So this would be, if I ignore this and say B plus starts here, then this actually works with an R10 coming out the top here. R10. Just writing it down, R10 out the top. This is two terminals of wires. So we know one of the wires goes to the screen of the 6A8. So that's that wire. Now there's another wire up here. That's coming over to this shared terminal. Oh, no, it isn't. Let's get the close-up camera going here. I'm gonna have my head in front of that. Okay. So we're looking at this black wire here. It goes from this terminal to this terminal. And then off of this one is this wire. And that wire is going up here. Now that supposedly is going to a resistor. Oh my gosh. I almost fell over. Myself in such a funny angle here. It appears to come to this terminal here on the tube. How does that work? And this one, yeah, you can see all the grounding down there. Again, I'm sorry about the bad focus here if I'm not paying attention. There's a ground terminal down there. This guy goes to ground. So it's basically B plus into here. And I think the B plus only gets here through this through this resistor, which didn't appear on the schematic. I got something quite wrong about that. So I think a B plus comes in here. Here, comes in here. It wouldn't make any sense for it to be here and to be here. I have all these resistors numbered wrong. And what I think it is not what it is. Well, let's go back to this terminal then. Here's one connection here, it looks like it's going to the screen of the 688. There's another connection going to a single pin on this tube. Let's count the pins. Just following it around as best I can. So the pin is this one, and that one is okay. That one is 1, 2, 3, 4. That's pin 4. Pin 4 on that tube, the second tube. Pin 4. Pin 4 on the second tube. Pin 4 on the second tube. Pin 4 on the second tube. Up here. This one. Second IF tube. 6K7. That's this tube here. That appears right here. Pin 4 is the screen. So far what I've found, or what I think I've found, is let's just find this line on the other page here. There it is, 42. There it is. So B plus does go through 42, which is the one that burned to smithereens but is okay now and runs cool. So he took a beating once, and then, well, how can it be that this isn't hot now? This is carrying all the same heating current that's flowing in 11. Plus, 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 more. And 11 is 20,000, let's say, and 44 is 50,000. 44 should be far hotter than, yeah, wow, okay, so this is hard for me to understand. What, like, there's a history to this heating thing, and how does that help? So, okay, so once again, just getting my head clear, it's R11 that is overheating. R11. I'm losing my mind here. So R11 carries only the current on this leg. Well, that's everybody. So R11's carrying everybody. And that's all. That's 4 tubes. 4 tube screens going through R11. If any one of these tubes is running wild for some reason, like plate current insufficient, leaving the screen current too high, voltage rather, plate voltage, depressed on one of these. Plate voltage is coming from the same line, but no resistors other than the resistance of this. So you gotta imagine the plate voltage must be higher than this. Is that true everywhere? Plate, no resistor. Plate, no resistor. What's this guy doing here? It's just, maybe this is acting as a screen in here? I suppose. Grid, screen. This is the screen. I don't know. Something going on there. Well, that would... Oh, okay. So this is a plate selector. Screen's up top. Plate. Plate is selecting through all these. There's a resistor there. Broadcast. I don't know. We might find that the current flowing in this resistor will vary a lot. One of the when I change a couple of switches, this switch must be an element in the band switch, so we can fiddle with that. Set up to measure the current here. First, we got to find R10. I never found R10. We must find R10. It's related to that switch, and then measure these resistances here, 4411 and R10. Then run the radio, measure the currents in them. Then make a determination or start popping tubes out here and see what happens to the current in R11. And we pull out one tube in particular and boom, the current will drop way off. Something like that might happen. Okay, let's go find 10, measure 3 resistors. Find R10, measure 3 resistors. Find R10. Where are you, R10? So R10 is supposed to be connected right where R11 and 44 join. Is there another hidden wire in there I didn't see? It's supposed to be related to the switch here. So here's a resistor on the switch. Goes to the chassis here. So this blue wire would, assuming these two go together and these two go together, this blue wire, where are you going, blue wire? You're going up on top. Oh, to the back of the volume control. What? Back of the volume control. It's definitely what it is. I don't remember that. From the switch, resistor, oh, that's right. The resistor is showing differently in a different position on the schematic, but let's go look again. So the switch I'm looking for is here. So yeah, so there it comes off the back of the volume control. And what they've done is the resistor is here in this leg to ground. Okay. So that is that. That is that. This one up here. So with this off, this plate gets no voltage, but the screen continues to. He says with an incredulous tone in his voice. That seems kind of weird to me. That you would interrupt the plate for sure. Actually ground it right out. No, you don't ground it, just leave it open. Leave it open. Then doesn't the screen become the plate? It's got voltage on it. Wow, so if this switch were in good shape, it would just be a question of snapping it back and forth and watching what happens here and there. And what happened to R10? What happened to R10? R10 is associated with, this is part of the band switch here. So you could have R10. R10 could be on anywhere on this wire. Anywhere on anywhere. It could be anywhere. Oh my gosh, in the back of that radio. It could be anywhere, anywhere. Oh boy. What's its value again? R10. R10. Something weird? Red, red. And this would be red, red, orange. Well, we're just going to look for red, red, orange. Oh my, there's another one here. How many are there? Red, red, orange. Red, red, orange. This is a crazy way to spot stuff, but there's a 22K here, so that'd be a red, red, green. Not a lot of red reds in here. Okay, let's go look for a red, red, something to do with screens. Red, red, red. Hey, okay. Let's just get a little more light. This might go a little too bright for the video. A red, red. Give me a red, red. That would be a red followed by a red. I'm all the way down to here already. Ain't no red, red in there. Ooh, look at these ones up here. It's one that's replaced. That's kind of interesting. There's one right back here. Nope, brown, black, yellow. There's no red, red. Body and dot. It's not a body and dot. So this one's a red, yellow, red. Oh my gosh, where is that resistor? I didn't find either. There's supposed to be two red, red resistors in here. I just shined the light right in the camera. Is that what I just did? I'm just looking everywhere to try to spot this. Well, maybe that's the problem. This resistor's missing. Huh. Wow. I'm going to have to look at every pin for those 4 tubes. It's the same pin every time, isn't it? Isn't that the case? I think it's the same pin every time. Pin 4. Pin 4. Pin 4, we're talking about the two tubes way up in there, which you can't get at, way up in here. And then we're talking about the 2 tubes here. Those are the 4 tubes that are supplied screen from this R11. From R11. Point to the right one, Jim. R11. So it could be hidden way up in there. That might be the case. If I look up in there, ooh, I see an orange, brown. That's not quite right. Ooh, you know what I see in there? I see paper capacitors. Oh boy, there's a whole bunch of schmozzle up in there. So, and then I see a lot of weird work done there. Very horrible looking capacitors stuck in there. Oh my gosh. Let me show you just a little bit closer what I'm talking about here. Let me look a little closer. So this is the, there's 3 sections here. Starting in the back one, there's no tube above or anything. So what do we see? It could be an original capacitor there, or maybe not. What else? Can you look through this really carefully now? At the same time, we're looking for a red resistor. Okay, let's try the next box. Oh my gosh, there's an adjustment down there. I hadn't noticed that. There's 3 of them. Oh boy, it looks like you got to come through the hole here with a screwdriver. I didn't even notice those back there. Okay. Good thing. See, I didn't attempt the front end alignment yet, so that's why my attention has not been drawn. Okay, back to this now. Oh, red. There's a red. So that's a 22K, red, orange. And that's what we're looking for, wasn't it? Can you remember? Okay, hang on a sec here. I'm going to be doing 3 things at once. R10, 22K, quarter watt. Well, that's probably it. You know, considering the fact every time I operate this band switch, I cringe at the feel and the sound of it. I think I'm going to have to really get into these. So see, he's got these old, they got to be second-hand capacitors he's stuck in here, right? Oh. Oh my gosh. Talking about cringing, just thinking about working down in there, trying to make an improvement in it. Yikes. So now, wasn't there, so see way down there's a molded capacitor and the tail end of what looks like a wax one hanging out there. Wow. Just how apart can this come? Let's answer that question, because just maybe this can come apart better than I realize. Like, what I'm really thinking about is can this whole coil set just come out? You can take these off easy enough. These come off, but then you've got the shaft going through the whole thing. So to lift out these switch sections, you have to extract the shaft. You know, that's close to committing suicide in these radios. I have a ham radio transceiver that worked bizarre for like a year, and I spent a long time looking at it and finally found out that 2 wafer switches. I'd extracted the rod, and when I put the rod in, somehow the wafer switches got switched around, and after that, no matter what you did with the switch, it was irrational compared to the design. Oh my god, my head came apart trying to sort that out. So that's why I'd be very reticent to try to pull this shaft out. I mean, there's a million problems with doing that, I'm sure. So, but wait a minute, I'm jumping the gun here. For this metal to come out, it has to have a slot in it for the, yeah, it does. In fact, there's a slot in this one. Why would there be a slot out here? They must have just made these panels identical all the time. There's no need for the slot here. That shows how it's done. Okay, so what about, so this piece is actually this whole thing. If I pull this whole thing off, I gotta go, I could potentially do the grommets at the same time in doing that. Pull this whole thing off. This wires over here. And have these plates off. And then there's there's these wires. It looks like it's possible to, wow, yeah, that's how it looks, but the reality is probably something different. It looks like I can just drop off these big support bolts, and this whole panel can be swung out this way. I don't need to worry about these wires so much, swinging it this way. A bit of interference going on here. Oh, that's all part of it. This whole front plate, this whole piece. Yeah, of course, this is the band switch. It's got to go with it. So this whole thing is coming off, coming loose except for this one corner. This is the only corner. And then the other wires has got the brake on here. And the other wires, these ones, are up in the same corner basically. Which means again I can swing that thing out, and maybe there's enough wire there. Maybe. Or it's not swung so much this way, it's swung up this way. And you can swing it this way. Well, that's possible too. I think that's even more possible. You can actually just take this top part without disconnecting those wires and just swing this up. Or I'd rather have it swinging down than up, but that's another problem. Get it up like this, I can't do anything with it. I can't work underneath here. So you lay this guy on his back, swing him around. It's hanging down. It's hanging down at that point. So there's a big hunk of metal hanging. So there'd be a lot of support issues with trying to support that big piece up front. Now, what would I have achieved having done that? So would I really gain better access up in here? Wow. Well, the first step would be to remove these panels. So remove all these panels, loosen off that top piece, swing it out, change all the capacitors that are in there, renew them all, renew everything I can possibly renew within reason, put it all back together. This is where we've gotten to here. What are all those capacitors doing up there anyway? Who says they're important? Who's saying that? Who's saying that? To top it off, my meter experiment's failing here because it's showing not much volume, but I think all is normal. That's okay. I gotta think hard about this. Okay, that's enough thinking. I don't have to think too hard to take these plates off. I can take the plates off. Let's take off the plates, because that's one step towards getting into the works here, and that can be done very easily. Oh my gosh, that just broke off, or maybe it wasn't even connected. Okay, so you know this is the deal with these old guys. The repairs break them. I wonder if that's what my doctor thinks when he sees me. Well, now we get a good view of the switch now. It's another really junky looking capacitor installed there. It just really does look like a junk box. A junk box repair. That's missing. So the band switch has to be turned in a certain position so it can escape the yeah, it's got to come through here. Doesn't look so bad working in here now. Doesn't look so bad. It looks much more possible. Oh boy, that's a tough screw. That's getting, what's going on? It's locking up. So it looks like the top of these, look what they've done here. You can see why this broke off. So this is a longer threaded bolt here. They screwed it on, then they took a pair of cutters and just cut off the excess. When you back the screw out, it runs into the cut off part and jams. From then on, you're turning the shaft, and then this is just soldered. It's going to rip off. So this is almost destined to be a failed thing. Now, somebody else did this. Why wouldn't these come off? Tell me they're the ones that cut the top off. No, son of a gun. I don't think I have any option here except just power over it. Oh my God, it's not going to power over. I can't even go back now. Well, what was that sound? I don't know what that sound was, but it didn't break off. This here one. Well, that's because I switched nuts, didn't I? Okay. Come on, just power it off. Just power that baby off there. Hey, isn't this magnetic? I wonder what kind of metal that is. Whoa. You're missing my funny little experiment here. So I just pulled this nut off, and I went to get it with my magnet grabber, and it's just the tiniest amount of magnetic grip. But look at the other ones it took off. It's a mystery, isn't it? It's a mystery. What about that guy? Hey. Okay. No explanation for it, and don't know why I should really worry about it, but that's definitely a strange thing there. Now I gotta put all these guys away. Right away. Pull off the last panel. Wow, can you see how that's been repaired there? Here's the original rivet. How about the other ones? Fixed. Oh, broken off again. Oh, look what he's done here. This is not the original piece at all. I think he's taken a piece of threaded rod, cut it himself, fit it in, found his own nut, magnetic nuts, and put them in. That must be what happened there. So, I'm pretty much on the same journey here. Wow. Okay, that's something to look forward to. Now, what do we got here now? What do we got to look at in here now? Now I can see down in here. I can probably not work in here. So there's that original paper capacitor, but you know what? Let me get the other camera here. Let's get the other camera. What do we got here? So we've got this weird arrangement of these large capacitors. For some reason, they're not terminaled. This is probably a ground terminal. And then over here, so that paper capacitor, I'd swear the lead has been cut on it. And then in behind it is a molded capacitor. There's the red, red, orange. Anything else in here? Delicate wires. On this side, anything to be. Once you start in here, there's no going back. Let's take a look at the switch in a second and see what we can see. Look at this capacitor. Like, where's he digging these things up? Here you can see the connection made to it. Down there. With this many junk box capacitors, there's a really good chance that some of these are not really the right sizes, or the size shown on the schematic. Okay, the switch. Well, we've got a chance to look at it. Let's start right in the back here. So I'm looking for bent things, things that don't look symmetrical. Is that a pile of dust? What is that? A little bit of dust on it. So now I'm looking at the track the contacts run on. Looks like a fairly rugged design to me. Let's see if we can see on the other side. Is there switches on the other side? Yeah. Contacts. Here's a better way of putting it. Appear to be in okay shape. Well, this guy's got two switch wafers in here. One contact looks all right. There's a lot of optical illusion stuff can happen here while we're doing this. There's a resistor. So this one, let me work the switch and we'll watch this one. That's one extreme. So you're sliding something underneath those fingers, and if it doesn't slide under well and catches one of them, you get a sound like that. I don't think it has anything to do with the ones we're looking at right now. There's another set up in here. So that sound could be, these are the stopper things. That could be what we're hearing. Just that. Or I'm tearing the switch apart somewhere. I haven't spotted where yet. Okay, I'm listening to the sound now. Huh, I'm not sure what's going on with that, how that's built there. It's a complicated little guy, that's for sure. Pretty sure this is what we're hearing, these rollers here. Yeah, I don't think it's the switch. Okay, so a bit of a panic there, thinking the switch has something mechanically wrong with it, and repairing something like that, I have no idea. You know, if one of these little tangs gets bent right out somehow, I don't know how you go about straightening that out. So good, that's why I wanted to dwell on that. So I don't think the switch is a problem. I think we're good to go here. Okay, so it clearly my first attempt should be to change camera. That's maybe what should happen here. I think it's quite clear. My first attempt should be to work on this just like this and not do any more trying to remove this part or anything like that. That's trouble with a capital T. So I think whatever the last person did, I can repeat. If he did it, I can do it. The question is way down in here. Worry about that when we get to it. I think that's probably the approach I need to take here. Sometimes you get just too much on your plate at once and you just lose your appetite. So now getting back to these overheating resistors, I think again I'm just going to go on the basis that I don't know how, but maybe some of these capacitors have something to do with it. I'm going to focus on changing these capacitors out. Try and do a nice job so no one's doing this for another 50 years or more. And I think there's almost certainly performance issues going on down in here. This is the front end of the radio. It's doing its best to pick up, you know, weak signals and focus in on them, so to speak. And bad capacitors up in here are not going to help that out at all. So I think that was a long journey to conclude that more capacitors need to be changed at this point. Well, thanks a lot for watching. Sorry this wasn't a little more interesting, but tomorrow we'll get at the capacitors and see what we get when we're done. Thanks a lot for watching.